Good morning and welcome to the webinar this morning. My name is Phil James and I'm the Availability Product Manager here at Solutions PT. You'll have to excuse me, I'm full of a cold at the minute, but I'll try my best to soldier on. And I'm joined by Chris Whitehead, who is our Managed Platform Aficionado. Hi Chris.
Good morning, Phil.
The title of the webinar this morning is Protect and Virtualize in One Step. This morning I'll just talk through the agenda. So we'll briefly go through some of the data collection market trends that we're seeing in the marketplace at the moment. We'll talk through the concepts of virtualization, the benefits of virtualization, and then some of the barriers that we see to people that want to adopt this technology and how they overcome them. And then Chris is going to talk about how we virtualize and protect the system in one simple step. And we'll also talk about some of the products that we utilize to achieve this service. And then obviously we'll wrap up at the end. So this is a study from the IDC from a year or so ago. And what it's really depicting is the trend that we're, as a collective really, collecting more and more data. So we can see there in 2015 where the study began to where we look to in 2025. There's a huge upward trend that we're collecting more and more data. I never really know how to pronounce zettabytes or zettabytes. But in 2019, next year, we're expected to collect 40 zettabytes of data, which is obviously a huge amount. And one of the things that we think is a driver for this is the IoT, so Internet of Things, and what that means really is the adoption of more and more devices that are smart and have the ability to communicate data, really to make our lives better really. So things like smart watches are really prevalent these days. Soon I'm sure that we'll have driverless cars, and when we look at the IoT, so Industrial Internet of Things, they're smart devices, or the adoption of smart devices that allow us to make more informed business decisions. So the trend that we're going to collect more and more data, especially at what we call the edge, so not in a true data center setting, has caused us to look at virtualization technologies and the adoption of those. So I'll quickly run through. I'm sure many of you know what virtualization is, but we'll just sort of set the scene, if you will. So the concept of virtualization really is a way of abstracting the software from the hardware layer. So we can see there one of the concepts is we're now hardware agnostic. The virtualized systems are a lot more scalable, so you can add more physical hosts to a machine to get that scalability. It's more flexible, so you can use different types of hardware. It offers centralized control, so you can manage your virtualized systems from a centralized location. And if you imagine from a utilization of resources perspective, if you have a conventional physical architecture or setup, you might have 3 or 4 servers that are all utilized at 30%, but by utilizing virtualization technologies, that allows you to consolidate many virtual machines onto fewer physical hosts. So those 30% utilized physical machines, you might be able to get 3 virtual machines onto one of those physical hosts. So that obviously ties in with the consolidation of servers as well. And because virtualization doesn't rely on the operating system living on that, closer to that physical layer, it means that there's greater system longevity. So with the software and hardware being abstract from each other, it means that you're able to run legacy systems for a much longer period of time.
Okay, thanks, Phil. So I suppose in my section, what I want to have a look at is some of the key benefits of actually going down the virtual route. So, you know, the first one and probably the biggest headline grabbing one is the long-term cost savings you'll achieve from being through a virtual environment or virtual system. Ultimately, as Phil says, you know, moving these legacy systems away from the hardware they're initially tied to and then keeping them running on, you know, modern infrastructure, obviously it's going to draw out your time between upgrades. So therefore, you know, actually, you know, that's going to save you time and effort in terms of maintaining and keeping that legacy equipment up and running, as well as the fact that if you're using less servers, obviously you're actually using a lot less power. You're actually consuming a lot less footprint in data center and rack space. So all these kind of small savings add up to actually being a fairly long-term cost-saving basis. We also then look at easier disaster recovery routes. So virtual technology has allowed other vendors to develop and expand on their current offerings to actually mean that once you're in that kind of virtual environment, there's many different ways to have a disaster resilience plan and actually have technologies that work so complementary with the virtual environments that it takes a lot of complexity away from being able to, you know, to protect multiple physical systems. Essentially, once you're virtual, we're just backing up one or, you know, a smaller number of virtual hosts. Now, this has also got additional benefits. In fact, being virtual means that essentially your virtual machines are just a bunch of files. So for testing and quality assurance, you know, or sandbox and development type work, a bunch of files can be copied and replicated. And if you've got the space and headroom actually on the virtual hosts, it means that you can very quickly get to a scenario where you have a live running production system as well as a sandbox and test environment of the same system. Now, given modern hardware can copy data at astonishing rates, means that you could take a momentary backup or snapshot of a running system and clone that machine out in a couple of seconds to then have the latest, most current up-to-date data to perform your testing on. Now, go hand in hand with that, if you've got a smaller footprint of servers, then you've got increased security. So like the little diagram we've picked to use on this slide, you'll see that there's numerous machines there. In a physical environment, each one of those machines has got CD drives that are accessible to end users, as well as USB drives and USB ports that are accessible as well. So therefore, you know, if you've got, for example, that scenario there, like 8, 9 machines that can be, someone could walk up to and actually plug a device into or put a, you know, an infected phone or, you know, other device connected to and actually spread that infection and actually, use it as an attack area for access to the system. Being in a virtual environment, all those physical elements are removed, and most of the hypervisors, when they're running in these states, are a lot more secure than a typical operating system. So things like USB isn't passed directly through to any one machine, the host layer doesn't use it itself. So just by moving to a virtualized infrastructure, then actually you are taking the first steps into improving that security model that you're currently running. It also says simplified management there as well, and essentially this means that if you were looking at, you know, a large fleet of servers, then typically to work in any one of them you're going to have to RDP into each and every one of them, or if you don't have that enabled across the network, then you physically got to go and access each one of these machines. In terms of also, you know, hardware repairs and maintenance, you've actually got to physically go and check on each one of these systems. So virtualization allows you to simplify the management by being able to connect to everything from one console. Being virtual, you know, there's minimal hardware to manage. We're not having to look at 8, 9 different hosts. You're looking at one. So actually, you know, the time and overhead of maintaining these systems can be significantly reduced. And obviously, the more systems you've got that are virtual, the greater that scale of saving becomes. And the last point there, and I've touched on this briefly, is that power and CO2 reduction. So if with a small footprint, it may not be as prevalent as a large footprint of servers. But if you've got, let's say you've got 10, 20, 30 servers, obviously that's a couple of years of rack space that you're actually going to save by going virtual because you're only having to run, you know, 1 or 2 or 3, maybe 4 hosts to run that number of virtual machines. But actually in doing that, you're consuming less power. And obviously consuming less power means there's less heat generated in the server room, which means you've got less cooling requirements. So actually, the benefits of going virtual do start to stack up quite quickly.
Just going back to your last point, Chris, you talked about simplified management.
Yeah.
Would you say that you'd need in terms of the skill set? Do you need in-depth knowledge of virtualization to be able to manage this kind of infrastructure?
It's a great question, Phil, and I wouldn't say it has to be specialist knowledge. It's certainly different. So once the machine is virtualized, the management of the virtual machine is no different than it will be with a physical system. The virtual infrastructure requires a different skill set. I wouldn't say it has to be in-depth, but certainly it's not the same as a physical system. So if you don't have that kind of skill set available, you know, there's many service providers out there who offer that kind of additional bolt-on support. But ultimately, once that infrastructure is up and running, generally it will need less maintenance than that of a physical system.
Okay. Great, thanks.
Okay, so what I actually want to show now is what we've seen is an upward trend in the last several years, and I appreciate this data is a little bit old. I've not got last year's or this year's data yet, but actually there's been a huge increase in the uptake in virtual technology. So what we see is if we look at back 2008, it was only around 20-odd% of systems that were deployed were actually using the virtualization technology. And that tipping point where there was actually more virtual than physical kicked in kind of 2011. So that's like 7 years ago now that the tide shifted the other way, and actually it was more virtual infrastructure than physical. And if we look at 2016, that was the last data point I've got, you'll see that there's like 84% of those systems are now virtual and physical, and we're seeing that replicate out through our customer base currently. We're doing more and more virtual systems and less physical. The benefits of this technology, the fact it is tried and tested, this is not bleeding edge stuff, this has been around for years, and the adoption of it has grown. So we kind of passed that chasm point where early adopters and it's moved into mainstream. Most people are comfortable with it. I would think that most people, when we talk about virtualization, have a good understanding of what that means and actually the benefits that brings and how they can leverage that to give them kind of the easier life of maintaining control systems and actually the flexibility and scalability that you mentioned earlier, Phil, to kind of bolster how they're delivering these kind of systems.
And I can see there, Chris, that there's obviously a real big upward trend in the number of adopters of virtualization, and you mentioned that Solutions PT have helped customers on that journey. Is there anything that we've learned, or is there anything that we should bear in mind when people are adopting this technology that we should be aware of?
Yeah, I suppose so. There's numerous factors to consider before taking on any kind of virtual project. If it's kind of greenfield, you're talking new operating systems, new hardware, then it's pretty much a no-brainer. There's no reason, and there's no real detrimental reason to not go virtual. And there's considerations, have you got the skill set to support it? Is it going to be something that the guys, your support team are able to deal with? And additionally, are you then going to have to retrain your team, your engineers, etc., to be able to use this technology effectively? And then I suppose the biggest overall question, is it the right fit for what you're trying to achieve? But in terms of legacy systems and virtualizing stuff that is already running, then there's further considerations, and these kind of form some of the barriers. Which, is the system that you're moving to going to be supported by the vendor? Is the operating system still in support? Does that make a compelling reason to look at upgrading and moving forward with the technology? So there's numerous factors to consider. Aside from that, you've also got the human element, which is people don't typically like change.
Yep.
So there's numerous factors to consider. So what we'll actually look at now is some of the barriers that we've come across in the last couple of years of when we've been looking at these projects. And by far the biggest one that jumps out at us is that kind of skills shortage. I'd say in the last couple of years, there's definitely identified as being an industry-wide skills shortage. So you've got less people to do the same level of work. I think everyone's familiar with that fact that everyone's got to do more with less, and now the levels of work are increasing. And that in itself brings a challenge in the fact you've got less specialists of technologies and actually more generalists. So therefore then adding something new that has to be onboarded, tested, and people get comfortable with takes a long time and might be too much for the current team to try and take on. We've also got the factor that if you want to look at high availability levels and increased levels of redundancy and resilience, that moving to a virtual architecture means that it can get complex. And I suppose complex is subjective of how much knowledge you've got of virtualization. But I think most people are comfortable if it's maybe a 1 or a 2 host system, but if you start talking 5, 6, 10, 20 hosts, then that architecture itself starts to get a little bit unruly, it gets very complex, and therefore adds to that skills requirement of having someone on site who understands that architecture, not only to operate it, but remediate it if something does actually go wrong. And that kind of ties into some of the support challenges that we see people facing. They've got legacy systems, they virtualize them, so they know how to use the software, they know the operating system, but then they don't really truly grasp the underlying technology. And this presents a challenge and it presents risks for people. So there's certainly ways to look at these, and we'll discuss these in a few minutes. You've also got the cost and time. Obviously, there's a cost to going down the virtual route, whether that's new licenses, whether that's new hardware, new infrastructure to actually support that. It may be that the current servers you've got were great for running one process and the one system, but actually they don't really fit the bill for moving out the virtualization model. So as you say, Phil, if you can kind of consolidate servers onto one host, then actually that host got to have enough power to run all that. And you may find that existing hardware doesn't and it can't support as much as you want to do with it. So it may be the time now to then look at new hardware to run that.
But if we are going to look at possibly consolidating servers into one physical host, does that not present, with the surface area of attack being reduced, is that not a security risk?
I wouldn't. There is risk to it. It's undeniable, and I think you'd be foolhardy to run a project like this without making kind of the due diligence checks that you need to, and making sure that you're happy with the levels of security and also the attack surface and understanding the threat vectors that would apply to it. But certainly that smaller footprint of physical servers to a virtual instance, I would say, improves levels of security rather than increases that security risk. There's a separate discussion around availability risk. Ultimately, if you're putting all your eggs in one basket, then you need to make sure that that virtual infrastructure is rock solid. You don't want that hardware falling over. You don't want that network dropping. So you've got to make sure that you've got adequate levels of hardware, even at virtual level hardware, and kind of software level redundancy. With best will in the world, you can have the most resilient hardware architecture available, but Windows is still Windows. You've still got operators that could click on the wrong thing, stop a service, or Windows gets itself into a twist, and we've all seen it where it just blue screens for apparently absolutely no reason whatsoever. Yeah. So there's still a lot of common sense in having the levels of redundancy from a software level, from a network level, and from a hardware level. So I think we've discussed some of the risks there, but certainly the biggest one that we come across, short the skill shortage, is that fear of change. We've got controls engineers typically, they've worked with these systems for numerous years, and they don't see the point in changing. They don't see the benefit, they don't see the advantage of changing the system, and actually some of them are just resistive to change because it means that they've then got to learn new software, new functions, new processes, and actually this adds to their workload, and they are resistive to kind of take on these new challenges. So, looking forward, how do we address some of these challenges? So, looking at levels of fault tolerance and availability, and Phil's going to talk around this a little bit in a couple of minutes. As we've just discussed, you've got to make sure if you are virtualizing your systems that the hardware infrastructure is there to support that. You've got the network level redundancy and also application and operating system level redundancy as well. There's still some common sense in that being your plan A. So if everything works properly and is doing what it needs to do, everything should work correctly. There's still that common sense factor of having a DR plan. You have a plan B if something does go wrong. So if the very worst happens and you get multiple points of failure occur simultaneously, that you've got that method of recovering and being able to get back up and running correctly and quickly. There's also a lot of advantages to looking at increased levels of support. So if that's not something you can do internally, either look at training the team to build on that, or partnering with an organisation that can actually give you that additional support where you've got the gaps in the skills matrix through your own team to deliver this. And then, we mentioned before complex architectures, and there's a lot of sense in trying to simplify that architecture to reduce the complexity. And there's ways in which we can do that, and we'll talk about this in this webinar later, of how we can simplify the architecture to ensure that, if something does go wrong, that there's minimal amounts you would need to do to get things back up and running. And that kind of leads into also moving from a reactive model of waiting for something to go wrong to a proactive model, so looking at continuous monitoring. So ultimately, if you can look at your currently running critical systems on mission critical applications, and also that, that mission critical hardware now, if you're talking virtual, and actually monitor that to detect what's going on with it, and look at elements before they go wrong and cause you downtime, then all the time you're going to increase those levels of availability. Now, we've talked about this very briefly already, but levels of software redundancy. And as I say, the best one in the world, Windows is always going to be Windows or whatever operating system you're running. That in itself, typically if it's well configured, shouldn't cause you too many problems. But you're always going to have operators, you'll always have new patches and things like that need to go on there. So if you have just a single point of failure through, you've only got one operating system running one process, and that stops, then you need to look at how do you bolster that, how do you improve that level of service from that one operating system. And typically the way we do that is run multiple versions of the system. So, if this is, for example, using a Wonderware reference, if it's like an InTouch system, then you would have multiple InTouch devices, multiple InTouch servers, or multiple AOS nodes. So if one fails, the secondary picks up the gap in that. So you're covered from a software level redundancy, but then also you've got your hardware level redundancy there if you get hardware failure. And last point is looking at that plan B, that business continuity and disaster resilience. And this tends to be the thing that people do after the event. So they wait for something to go wrong and use that as the trigger to then look at, well, what do you do if it happens again? So I would definitely recommend that people look at doing this before you're in that scenario where it's 7 o'clock on a Friday night and everything's currently offline and working and the boss is screaming at you to get it up and running again. So make sure you've got a well thought out, comprehensive continuity and disaster resilience plan. So a backup solution, whether that's spare hardware sat in the corner to be able to restore stuff to, whether that's cloud-based technologies, but ensure that if something were to go wrong, that you do have that route to recovery and test it. Most people put one of these in and then never test it. So absolutely make sure your plan A is covered, that everything's going to work properly, but also your plan B is there as well if something does go wrong.
Great info, Chris. Just want to talk about one of the products that I look after that sort of fits in this space really well. So as Chris has just mentioned there, potentially people are going to want to consolidate servers, or consolidate machines onto one physical host. So why not make that physical host, a best-in-class in terms of uptime and the hardware continuing to run. So the ftServer, we've got a picture of it there. Visually, it's two servers strapped together, but if you were to look inside those servers, you'd see the same x86 architecture, the same leading best-in-class components from the likes of Intel and what have you. So in terms of the components, it's very similar to a standard office-grade server that you would see elsewhere. But what makes it unique is what we call the automated uptime layer. So there's a piece of proprietary software and FGPAs that reside in both servers that allow the machine to work in lockstep. And what I mean by that is that each computing task is done at exactly the same time across both servers. So that means that it can suffer multiple failures really. So if you've got a stick of RAM that fails in the top slice, the bottom slice will continue to run, and that identical component in the other slice will continue to take over. And it could be the same with hard drives or even processors really. And another thing that sets the Stratus server, the ftServer apart is the way that the active service architecture works. So the way that this machine is supported. So if we imagine that a machine has suffered a critical failure on one of these slices, we call it going into simplex mode. So you're back down to one slice of the server functioning correctly. What will happen is that the system will automatically diagnose itself, take one of these subsystems offline if you want it to, and then it will dial home. The technical support team at the Solutions PT office, the support team at the ftServer locations, they're notified of these issues, and the server, the ftServer, can actually dial home and order the correct replacement parts. So if you imagine if you have a consumer or office grade server that suffers a failure, what will likely happen is an engineer will come out. The chances are he might think it's a sticker RAM, or he might think it's a processor or a hard drive, or whatever it might be. That engineer will turn up and try to fix the machine, and while that's happening, you as a user are suffering downtime. So what the ftServer will do is it will continue to run, and you will actually, next business day, receive a secondary slice, a replacement slice. So rather than it just being a stick of RAM or a processor or a hard drive, you will receive a complete slice. So it removes that doubt, really, that what if what we think was wrong with it, that isn't the case. So if you send out a complete slice, you know it's going to work. And with them being hot swappable customer replacement units or replaceable units, that means that you don't need these, any specialist IT knowledge to replace or repair the server. So it's very easy. It's just some thumb screws. The new slice turns up next business day, and an operative can remove the old slice, replace it with the new slice, and the system is intelligent enough to get itself back in sync, to get itself back in what we call lockstep. So if we look at that in comparison to some of the other ways that you could try and achieve high availability, if we look right on the left-hand side there, we've got a standard server. This is a standalone server. It's never been designed for high availability, and I've just mentioned there it's a single point of failure. So if something goes wrong, immediately you're suffering downtime, and potentially you've got to wait 1 to 4 hours for a service response from an engineer to try and rectify the issue. And if this is in a site where it is remote, it isn't in a central location where you have somebody that can get out to the machine, whilst it's down, you're continuously suffering downtime. But if we move on to the right, we could talk about clustered solutions. So this is using those same standard servers, but introducing at least 2 of them in what we call a clustered environment. So in this sort of scenario, you would need at least 2 servers. You would require at least 2 networking devices and some sort of storage away or SAN, some shared storage. And what happens here is there will need to be complex scripts to make your applications cluster aware, and some sort of in-depth knowledge, IT knowledge, who understand these clustered environments to make sure that everything ticks along nicely. But even with all that, it's still a system that at best is going to fail from a recovery. It's not going to prevent downtime. So if you imagine one of these servers fails, any data that isn't committed to disk at the time of that failure is lost. So we call that in-flight data. So like I say, at best it's going to try to recover quickly from a failure. It's not going to prevent any downtime. And then if we move across to the right-hand side again to virtualization, there's a way of achieving that same sort of model, but with virtualization technology. So VMware, for instance, offer a service. So it's the same kind of principle. You won't need the scripts to be able to make your or to have to make your applications cluster aware, but you're still going to need those additional networking appliances, shared storage, and at best it's still going to only recover from a failure, albeit quickly in some cases, but it's not going to prevent downtime. So if we move across to the Stratus server, this offers at least 99.999% availability, so at least 5 nines of availability. If you head over to the Stratus website, you might see an improved figure from that, but at least 5 nines. So this is the only system that is going to prevent this loss of in-flight data that's committed to disk at the time of failure, because both slices are doing exactly the same compute tasks at the same time. So rather than trying to recover quickly from a failure, it just doesn't fail. It prevents downtime, and it's designed to prevent downtime.
Well, it also looks like actually that the Stratus box just being a single server would be a much more elegant solution. You've not got all that overhead of that clustered solution to actually improve on those levels of availability.
Well, if you imagine it's a great question, Chris. If you imagine the architecture of the system, it's one box, very easy to manage. You don't need in-depth virtualization knowledge. And in terms of the applications, they don't need to be cluster aware. And logically, it's one server, so you only need one copy of your Windows operating system license, one copy of your other applications on there. So you don't need multiple copies that are cluster aware. So.
Oh, okay. And if we play devil's advocate, if something were to go wrong on the Stratus server, let's say we get a component failure, what would actually happen?
So you'd be notified in the management interface of the machine that potentially there's a failure. Automatically the server's going to dial home and report this problem. The system at first protocol is going to try and diagnose itself. A worst case scenario, the machine will dial home, order a replacement part, and that will turn up next business day.
Super.
So if we just look at what these availability figures mean, so I'm talking about 5 nines, on a daily basis, but what does it actually mean? So that conventional server, that standalone server, is only 99% available, which sounds great, and I would imagine if this was just a mail server or something, it was just running Outlook, I'm sure that people can deal with mail being down for an hour or whatever it is, albeit you'll have some disgruntled employees, but we can live with that, right? But when you look at the 99% availability, that equates to about 87 hours of downtime a year. So in an industrial environment, maybe in a manufacturing environment, it just isn't appropriate. It isn't acceptable. So if we move through and look at the other solutions, a high availability cluster that we talked about before, that's 99.95% available, so over 4 hours of downtime. So when we look at the Stratus element, at least 99.999% available, we're looking at only 5 minutes of downtime on average a year. And like I said, if you go onto the Stratus website this morning, I'm sure that you'll see a higher figure quoted there. Recently we've seen 6 nines, which is about 30 seconds of downtime a year, which is fantastic.
Okay. So now we get to the real core part of this webinar, which is how we're going to look at protecting and virtualizing in that one step. So, for example, on the diagram we've got on screen there, we'll see we've got a couple of physical systems here on the left, and on the right there we've got the where we want to be, which is where they're actually running on a virtual environment. So, looking at this, essentially what we've got here is one of our other technologies we'll talk about shortly, which is the Proteus technology. So, our backup and business disaster resilience solution. So essentially, with the Proteus fault, we back up and protect those 3 physical servers, so the domain controller, the Thin Manager server, and also the InTouch server. And once that data is protected on the vault, that's the first step, we've got it protected. So if something were to go wrong with any one of these processes, we can very quickly recover that back to that physical hardware. But actually one of the other benefits of the Proteus system is we have a direct hypervisor upload option as well. So therefore we can take these now protected machines and we do a full image-based backup. So actually once we've got that image backed up, we can then directly upload that onto an ESX server or a Hyper-V server. In this instance we've got VMware listed there, and essentially then spin them up as virtual machines. So as we've just been talking about, if we are going to virtualize stuff, we need to make sure that you're putting it on the best possible hardware for that environment. And it certainly sounds like Phil's got the right idea with the ftServer being the best in class for what we're trying to achieve. So with the Proteus Vault protecting the physical systems, we get those virtualized and actually uploaded to the VMware server, and then we've also got the Proteus Vault acting as a backup solution for that as well. So once the actual machines are running on the VMware host, we're still backing them up to the same Proteus Vault. So we should we have any problems with the actual machines, we can restore those backups very quickly in a matter of seconds. So the high-speed data traffic, data links between the Vault and the hypervisor mean that the full image-based backup can transfer like 10 gigabits a second. So it literally zooms across, meaning that, you know, in the event of a system corruption rather than hardware-based failure, then actually we can get that information back up and running very, very quickly. So that leads me into talking very briefly about the couple of the products I looked at after, and this is Proteus. So at a headline, Proteus is our fully monitored 24/7 BCDR, which stands for Business Continuity and Disaster Resilience. You'll hear me use that acronym loads of times throughout the rest of this webinar now. So essentially, we maintain and monitor all the backups that you tell us to for the systems you deem as critical. We use the latest in hybrid cloud technology, so we back up locally to the Vault actually on the local network, and then using secure outbound connection, we replicate that data offsite as well. So it's a private UK cloud data center. So, you know, if you've got legislative purposes, you need to know exactly where that data is. When it's at rest, then we can prove, you know, to the individual spindle where that data is held. Also, we've mentioned security quite a bit. It's a very, very hot topic at the moment. So for any data we've got in flight, so moving it from the physical system, virtual systems, to the Vault, that is encrypted to AES-256. And the same for anything that's in transit to the cloud as well. So if we're moving it off the Vault and to the cloud, that also gets encrypted there.
What about while it's in the data center, while it's sort of at rest? Is that encrypted as well, Chris?
Yes, it is, Phil, and it is true AES-256 encryption. So when we set these backup points up, if you wanted to encrypt that backup, we would ask you for the encryption key you wanted us to use. And this is where it can be a stumbling point, purely because if we encrypt it using your key, it isn't like we've got a backdoor into the system, we can't unencrypt it if you lose your key. So it's absolutely important, if you do want that in data encrypted at rest, that you've got a robust method of retaining that encryption key should you need to decrypt it in future. That's a great question, thanks Phil. So we've also got daily screenshot verification, and this is what sets us apart from typical backup technology. So most people who run let's say, generic type backup technology will take a backup, and you get a little email that's generated that says, yep, your backup is completed successfully. And I would say it's in the 90s of the % of people that take that email as being gospel, that it does actually work. And typically, you'll find out it doesn't work when the proverbials hit the fan and you really need to make that system back up and running. And that's when you find out that the backup's not completed properly, your data set's incomplete, and your backup's absolutely no use to you. So we proved every day our ability to restore that data. So as we mentioned, you know, any system we've got running is a full image-based backup. So we spin those backups up actually on the Proteus Vault as a virtual machine. We get it to its login prompt. We know that system's bootable. We take a screenshot of that logon screen or the desktop, depends how it's configured, and that gets emailed to you. So we've got provable points every day that we know that data can be recovered. Now, the way we actually do the backups, we only take the delta change each time we take a backup, and that allows us to apply a lot of sensing and algorithms to look at the backups in detail. And one of the biggest points we've got with that is ransomware detection. So ransomware, you know, there's like 500,000 new signatures found for it every day. Trying to keep those systems up to date to look for every strain of ransomware is a nigh on impossible task. You'd never get the time in day to make sure and prove all those updates have taken to each vault, every day, every couple of minutes. So actually, we use something called behavior-based analysis rather than signature. So we're not looking for individual strains. We're not looking for CryptoLocker or TeslaCrypt or WannaCry or Petya or any of the other ransomware flavors that are out there. What we're actually looking for is the behaviors that these ransomwares actually exhibit. So mass amounts of delta change, operating system files okay, but personal files actually then become encrypted and they'll end up in like an ECC file format. So without getting too far into the technical elements of the algorithm, that is essentially how we use behavior-based analysis rather than signature to look for ransomware infections. And also we've got the ability to instantly virtualize the system. So let's say you are running a Stratus ftServer, so you've got best-in-class levels of availability, but it doesn't stop the power going out. So if you've got your Proteus vault in another location, which is what we typically recommend to give you that geographical separation, if the power goes out in your server room, obviously, you need to get things back up and running quickly. We've actually got the ability to take those backup points that we take fairly frequently and actually spin them up on the vault as a VM and present it back to the network. So if you've got your plan A of your fully fault-tolerant, redundant network and storage and servers, and something does go wrong that it takes out an entire server room, it could be a severed fiber cable that takes an entire room offline, then as long as that vault's in another room and it's powered up, we can get them machines back and running in a matter of seconds. So a little bit more about the actual solution. So we have the ability to do hardware-independent restores. Now this probably doesn't apply as much as to virtual technology more than the physical. So if we're backing up physical systems and you are running a physical architecture, it means that you don't have to keep the same hardware available to do restores to. So a typical image-based system, that image is only good for the same model, same spec, and same build of hardware that you then want to restore it to. With the HIR systems, hardware-independent restores, we can take, for example, an HP system and back it up, but actually then restore that to a Dell system. And part of the process is, as we boot the system to actually perform the restore, we query the new hardware and find out exactly what drivers it's required to have injected into it to then make that system fully bootable. We also run what's known as an inverse chain technology. So this is designed to keep the backup stack as quick and efficient as possible. So we don't consume loads of overhead of CPU while we're actually taking the backups, and it also keeps the backup file sizes to a minimum, meaning in the event of having to restore something, it happens very quickly. Now we've also developed recently something called backup insights. So these are, again, all methods to actually get you to that restore point, access that data more efficiently. And if you've worked in IT for any point and you've dealt with backups and restores, you're probably familiar with that conversation where somebody says, I've lost these files, and you say, okay, when did you last see them? Well, I'm not sure. I don't know if it was last Monday or last Tuesday. So if you're taking backup points every hour and you narrow it down to Monday and Tuesday, that's still 48 backup points you've got to look through to find these files. So backup insights allow us to compare multiple backup points visually and see the file differences. So the file structure changes when new folders have been created, deleted, changes in file size to individual files. So if you know that you have a window where it's like Monday to Wednesday, we can compare those backup points and use a visual representation to look at the data changes between them, meaning you'll get to where you need to find that data to be restored faster than you would if you happen to trawl through all those backup points individually. So, moving on, obviously we've got full ESX and Hyper-V support, so they're two market leaders in terms of virtualization technology. Quite happy working with either one of them both ways, so backing up and restoring to it. And in terms of sizing the solution, then actually, we've got from 500 gigabyte boxes all the way through to the very, very large 120 terabyte solutions. So whether it's just a small footprint of servers or whether it's mass servers across multiple sites, there is a Proteus vault that will fit and meet those requirements. So I think back to you, Phil.
Very interesting, Chris. Right, we're at the final hurdle. I'd just like to summarise really what we've discussed today. So hopefully during the webinar we've outlined the challenges that we're seeing in the market, which are focused on our customers' attentions to protect their critical plant processes. The adoption of virtualization technologies brings many benefits, and it's enabled key applications to be migrated to a centralized physical location. We've also discussed some of the challenges which can arise when adopting this technology. Migrating critical applications from many physical machines to fewer physical hosts can mean that there are security threats or even downtime should these hosts fail, and it's imperative that the correct high availability solution to run these applications is considered. I suppose it's also important to protect these critical processes with a solution which enables the system to be recovered in the result of a disaster, both quickly and with as little skill and effort as possible. Both ftServer and Proteus are complementary technologies with each other, and when you use them in tandem together, it enables you to protect and virtualize in one step with little IT knowledge and in as little time as possible. using both can simplify the virtualization process while reducing risk and improving availability of critical processes.